Let's get into the second part of our presentation, which is about this brand new product that we're very excited about. It was recently introduced, and it's called Elastic Machine Pools. Hi again, I'm Madhura Maskasky. I'm co-founder and head of product. And
I'm Peter Frey.
Awesome. And so what we're going to do now is we're going to kick off with intro and overview of EMP, and then Peter will show you live everything that I discuss in the form of slides. Okay, so let's start with the first question. What is EMP, right? So EMP in a nutshell, it's a new, we think, revolutionary compute engine that is specifically focused on helping you optimize utilization, compute utilization, when running Kubernetes in the public clouds, okay? And as a side effect, we hope to also help save people about 50% or more of their cloud Kubernetes costs. And so that is the core of what EMP does. And so naturally, the next question I think that it lends to when someone finds out that we're building a new product that's focused around cloud cost optimization today is, well, isn't that an entrenched market? Like, isn't that a solved problem? There are so many tools that are out there. What makes EMP unique, and why did you feel a need to create a product? Right. So I think to answer that, I usually like to go back to a stat, which is kind of the core of some of the data that led us to believe that there is a problem that needs to be solved today, and that's why we created this product. And so usually when I show this number to people, sometimes it takes them by surprise. But this is our observation now based on our own Kubernetes environments, because we run all of our stack behind the scenes on Kubernetes, as well as what we've observed across hundreds of customers running both on public and private clouds, Kubernetes, is that Kubernetes in general is one of the most inefficient consumers of infrastructure capacity. Right? And people usually kind of takes them by surprise because there's an assumption that Kubernetes does a good job at resource consumption. But if you think about it, Kubernetes, yeah, go ahead.
So I'm assuming what you mean by that is that it's utilization of the servers is at 30%.
That's right. So what I exactly mean by this—
server utilization or what?
It is the utilization of the worker nodes. They could be servers, VMs, but you're right. It is the average utilization across all of Kubernetes worker nodes. When you gather it at a certain frequency and then average it, let's say, over months or a year, tends to be at most 30%. And this would be across CPU or memory, whichever is your constrained resource. Yes?
Is this from a study that you published?
So this is based on data that we've gathered, but it's also corroborated by similar reports that are run by— there's multiple, but one that I like to reference is Datadog has done this extensive analysis on all of their Kubernetes environments, and they've come up with the same thesis, which we've also collected through our data. And what they say, for example, is that 45% of the containers out of all Kubernetes environments that they've observed use less than 30% of the requested memory. Right? And memory tends to always be the constrained resource. And so that kind of goes towards that fact. And so
I'm surprised it's that high.
What is that?
I'm surprised it's only, yeah.
As someone who ran VMware clusters
Yeah.
for a long time, I always know that people tell me they need 12 gigs, 16 gigs of memory, and I need 2.
Right? Yeah.
That's more.
Exactly.
I think it's
That did go away with containers.
That's right.
Worse than that, but people aren't being honest. But yeah, that's—
No, you're absolutely right. In fact, 30% is very much on the optimistic side. In reality, I think people pat themselves on the back if you get it above 20, like if you're able to see that 20% utilization number.
I feel like this study needs to be more— 30% of people know how to actually optimize Kubernetes versus it being most efficient. Because I can tell you, like, right off the bat, this number, if you set up proper resource optimization, if you set up proper cost optimization, if you set up a couple of different tools, even if you set up proper worker node auto scaling without something like Carpenter or without any other tools, this number wouldn't be entirely accurate, because that's all pretty much automated for you, whether it's cluster autoscaler out of the box, whether you use something like Carpenter, if you're using resource quotas, if you're using requests, if you're using limits, this stuff is very straightforward. But like I said, I think this number should be more of like the people that know those things and how to set them up properly.
That's right. Yeah, no, I totally agree. And I think that kind of correlates to why most environments, which are not set up by the experts, tend to be horribly underutilized.
Right.
Right?
I agree with that.
Yeah. Yeah.
So is it just that people are over-provisioning based on some of the other comments, right? Over-provisioning because they think they may need this much.
Right.
But in reality, they honestly don't know because they aren't using the right tools.
Right.
Or just haven't done the work.
Yeah.
That's
or
right.
planning ahead of time.
all of the above.
Yeah.
All of the above, and we try to dissect
Let
that.
check all
Yeah.
those boxes.
Yeah,
Yeah.
There's probably
That's right.
5 other boxes I'd add
That's
to
right.
that as
Wow.
well. But
Okay.
yeah,
Right.
people are
Gotcha.
it's that, but then it's also just
clueless
setting
on
up the stuff
site.
out of the box.
Which isn't their fault. Clueless.
Yeah, so I mean, I think that's a great question because that's exactly what we try to dissect in the next set, right? Which is what are the contributing factors? And like he said, I think in every environment, if you pick a random environment, there will be 20 or 30 or 50 different specific reasons why their environment is inefficient. But on a whole, we think that it kind of falls into these two categories, right? What we like to call the bin packing wastage. And this is where tools like Carpenter you mentioned, they try to make the biggest dent in that bucket, right? That's the bin packing wastage. What that is, it is, my app, it needs 10 GB of memory. The best EC2 instance I can find is 12 GB memory. Those 2 GB, no other app is going to use it. It's always going to go waste. That's just one simple example of bin packing wastage.
Provision by 20%.
What's that?
And you've over provisioned by 20%.
Right. So that's the solution to that.
1,000 times.
Right, exactly. So, so that's the first bucket, and it's surprising just how much of the wastage across what we've seen actually falls in that, just bin packing wastage bucket. And here again, we could go into details of how Kubernetes, once it schedules, it never really is going to try to move that workload to another node unless, some other event kind of forces it to, et cetera, et cetera. But then there's this second bucket, which really isn't tapped into by any tools, et cetera, that are out there today, right? We think. And we call it the allocated but unused capacity. And this is where I'm a developer. My app needs 14 GB of memory, so I've set my request value, and I set my request equal to limit, so my quality of service is high. That's what I want for my app. I set that to 14 GB, but for 90 to maybe 95% of the times, my app is going to only use 2 GB of that 14 GB. And so for majority of that time, that remaining 12 GB is just sitting wasted. Right now, during those 5 or 2 or 3% of the times, my app will actually need all of that 14 GB. So I have to set that request, or at least the limit to 14, because otherwise my app is going to get killed. In fact, if I don't set my request to 14, there is always a chance that my app will get killed by Kubernetes. Right? And so I have to set that amount. Now that amount is never going to get allocated to any other app by Kubernetes, just never going to free it. And that's what goes into this allocated but unused capacity bucket. And what's surprising is many times, going back to what you were saying, even when we've noticed enterprises measuring their utilization, they somehow don't even account for this factor. It's not even properly accounted for. But so that kind of, and this is just like one example of a design partner we're working with. In their case, about 48% of their capacity was wasted due to inefficient bin packing, and about 35% wasted because of apps that were just not using all of the capacity given. Now, in other examples, this yellow bucket may be very small, maybe if you're using Carpenter, but the red bucket would still be high.
Yeah, but unfortunately, again, with something like this, like wasted due to high resource requests, totally understand, right?
Yeah.
We're not even talking about limits. We're not talking about quotas per namespace. We're not talking about quotas per worker node. This wasted resources, this has nothing to do with Kubernetes being a waste or Kubernetes being inefficient. This has to do with people not having enough forecast information for their containerized applications. So, what I can tell you is, let's say you're using some type of software. I'm not going to mention any other vendors, but let's say you're using some resource optimization tool that you have some type of forecast or some type of reporting based on your containerized application. If you're an e-commerce website and your busiest days are Black Friday and Cyber Monday, and you get that data per year, that's going to help you with this way more than any other tool, right? Having that forecasted report and that information. So it's less about Kubernetes being inefficient, and it's more about people's data being inefficient because they're not looking at that data. And it's the same problem we've had with bare metal, right? Bare metal was the same thing. We had these servers, we used 20% of it, 80% of it was being used. So then we got virtualization.
Right.
Virtualization was the same thing. We gave it a VM 16 gigs of RAM where it only needed 3. So it's the same problem we've been facing for the past 30 plus years. That we don't solve it with tools, right? We solve it with gathering the right information, the forecasted information, the forecasted reports based on how application stacks are reacting to traffic versus chucking tools, right?
Yeah. That's definitely one way of solving it, right? And that's very common today as well. The right way of solving it today, based on the tools that are available, is like you said, you have to have good observability where you collect that data, and then you use that. Ops teams use that to work with developers to make sure that your request limit values are really configured properly. And that gets done a lot. But in our experience, actually, First of all, it's a cumbersome process. It's a tedious process. I mean, I've known companies where every Monday they run these CloudWatch or Cloud Health reports. Then they have to sit down with developers because 5 new apps got built during the in the meantime, and now they have to apply the same policies to those apps. So it's just like that cycle. The other important factor of this is if I'm a developer, and I've been a developer in my past life, I'm measured on the KPI that my app SLA should not get compromised. If there are incidents happen, then I immediately get impacted by that. I get asked questions. Did I not write good quality code? And so if I have an app, for example, that runs Elastic and it's Java-based and needs a lot of memory and et cetera, I'm gonna set that request limit quality of service value to a reasonably high number. Maybe you negotiate with me, I'll bring it down by 2 GB. I'm not going to bring it down to 5. I think my app going to need 14, right? I'm not going to try to take that risk. And so there is a resistance from developers in changing this. And in fact, FinOps.org runs this fantastic survey, State of FinOps report. They've run it twice now. And they ask this question, what is the top challenge? They ask it to the FinOps practitioner. What is your topmost challenge or set of challenges in making sure the FinOps practices are actually implemented? And twice in a row, they listed empowering engineers to take action, which is this loop we're talking about. Empowering them to change these configurations is the most difficult thing, is the highest challenge.
Just to get them to take action
Exactly.
is the topmost thing, because they have
Right.
SLAs, they have uptimes, they have other things to work out. They just don't want to take the risk. They'd rather build things.
Exactly. That's exactly right. Yep. And that kind of goes into that loop. And I mean, the observation we had, yeah.
It's interesting. I was literally just going to ask you a question
Yeah.
about FinOps. We're starting to see the sort of most advanced FinOps platforms not just be the reporting and TCO, but then try and come backwards through automation into workload placement and kind of tune. So this is why it's really expensive. Now move it and put it somewhere cheaper and drive that back through automation.
That's right.
Are you starting to see that loop come from tools like Aptio and others in that space? Have you got the connectors in place because a lot of these people are looking at that from a FinOps perspective and then trying to drive it back towards infrastructure. You've seen that connector?
That is exactly right. It is these tools, our Aptio Cloudability, there is Cloud Health, there is KubeCost, there's a bunch of these tools, right? And they strive to make that loop easier by giving you as much data as possible. So they want to empower you with data.
But I'm seeing them not just provide the data. I'm seeing them want to come back through, and IBM's doing this with Aptio and is going to attach it to Ansible. Be able to get it to come all the way back so that you've not only got the decision making, but you can force that decision back onto infrastructure.
To the action, yeah.
Are you starting to see that come?
Yeah, and in fact, that's kind of the next thing that we talk about, which is so at the base level you have just the visibility apps, like you said. They'll give you all the data at various granularities, and they empower you. You go take action. Then there are apps that go one step further and try to take actions on top of that, right? And the most common action that's taken, and Carpenter kind of does that in an interesting, different way, is trying to right-size those instances on your behalf, right? So here I will observe that your request was way higher than your actuals. I will try to tweak your app config and change that. Right? There are a number of side effects around it that we can talk about. One is that at least today till Kubernetes 129 or 30 or so, reconfiguring dynamically your application request and limit required a pod restart. So there are those limitations, around doing that. Essentially, what that means is that your app SLA is compromised, right? And that was one of the big thesis for us, is that we wanted to build something that does not compromise your app SLA. But so essentially, what we notice is that all of the tools that exist today operate in the first 3 buckets here, but none of the tools are trying to attack that compute optimization problem at a layer below, which is where we think it can be automated and addressed in a unique way, right? And so, drum roll, that's basically what we try to do with EMP. So what EMP is it's a new offering. It is focused today specifically on Amazon and on EKS. However, the technology, as you would understand, is nothing specific to Amazon or EKS, and in future we plan on expanding it to other clouds. But today, what EMP does is it allows you to maximize your EKS cluster utilization. Okay, so I like to say that EMP has the two most important kind of goals for it. The first one is maximize your EKS cluster utilization. But the second one, which is just as important, or I would say equal or even more important, is that it needs to do that while not impacting your application SLA at all. So there should be zero pod termination, zero app disruption, no changes required to your applications, not like these 10 Kubernetes commands you can't execute because now you're using this tool. It should just be seamless. It should not impact your SLA, but it should help you save costs. So that's kind of the thesis behind EMP. Now let's look at how we do it, right?
Oh, sorry.
So, yeah,
I'm sorry.
go ahead.
The previous slide, it says no changes to cluster or app config required.
Yeah.
Right. I just want to confirm here. No changes to cluster. There's obviously something being installed, right? Whether it's a Helm chart, whatever it is, right? So there is some type of change occurring on the environment. It's not like an agent that's running on particular worker nodes or anything. It is a configuration on the cluster itself.
So you're right. I think that probably should get modified to say, what I meant by that is we don't require any fundamental changes to Kubernetes or the technology in a way that'll restrict your usage of clusters, but there is a change to clusters, meaning we supply you with different alternate worker nodes, for example, and we'll talk about that in a bit, but that's right.
Okay.
Yep. So let's kind of peel the onion and figure out, or get into the details of how EMP does what it does. So we start with a simple concept. Think of EMP as an intelligent autoscaler for your EKS clusters, right? That's kind of how we plug in as well. But then what we do is instead of your regular EKS cluster that will deploy worker nodes as EC2 VMs, instead we go straight at AWS bare metal layer, and we will provision on your behalf bare metal nodes, and we'll create a pool of these bare metal nodes. And then on top of that, what we deploy, we deploy what we call these elastic virtual machines. Okay, so this concept EVM, you will see that referenced. These EVMs, they look and feel exactly as your EC2 worker nodes, but they are highly optimized to be, better consumers of the resources given to them. Okay, so that's key thesis behind EMP. It's pretty simple, but I think what it allows us to do, I think it's powerful. Because we are deploying at the bare metal layer, we're now able to leverage, I would say, a concept that was used back in VMware times, multiple times, right? Which is over-provisioning, which is, you kind of base off of the fact that not all virtual machines that you're going to deploy are going to consume all of the capacity that they're configured with. So what you do is you pack more virtual machines on fewer bare metal resources. So if I have 10 VMs, each requires 5 GB of memory, total 50 GB. I will put all 10 of them on a single server, which is physically configured with 25 GB of RAM. And by doing that, I'm betting on the fact that none of those VMs, in that case, extreme case at least, none of those VMs are going to ever use more than 50% of the allocated memory. Right? So that's kind of one thesis of EMP. And I think you would say, well, this works fine, except for the case where, well, maybe 70% or 80% of those VMs now start requiring more than 50% of the memory. What happens then? Right, so to address that, there is a second key component of EMP. It's a patent pending component. It's called the rebalancer. And it is something that runs behind the scenes 24/7. It's running in your AWS environment. It is collecting metrics. It's collecting data about the bare metal nodes, the VMs. It's very aware of your application and its resource needs, the request limits, etc. And its goal is to create an even distribution of capacity consumption across the pool of bare metal nodes. Okay, so if the rebalancer detects on a given bare metal node, the BM1 here, that all of the VMs are starting to consume, let's say, higher than a certain threshold of memory, which is in turn pushing the bare metal's memory consumption above a certain threshold, it's going to migrate some of those virtual machines to other bare metal machines in the pool. So its goal is to create more or less an even distribution of resources across the pool of bare metal nodes. Right? So in doing so, what we are able to make sure is that before that application inside those VMs is reaching a point where it can't get enough memory, it's going to crash, et cetera, we're able to give it enough resources. And so the app SLA is not impacted.
So question on that, I'm
Yeah.
going to get back to the data. So if I do a live migrate, what are you using to do the live migrate, quote unquote, the live migrate? And is that enabling persistent storage to be persistent data to migrate as well?
Yeah, no, good question. So we deploy virtualization on those bare metal nodes, and on top of that, so KVM virtualization using KubeVirt, which is a Kubernetes component. But essentially, KVM virtualization enables live migration of virtual machines.
Mm-hmm.
It's something we've worked on several years. We worked at VMware as well previously, but this is the open source KVM, and live migration capabilities that come built in with it.
Okay.
And that's what we use. And yes, it is able to migrate your persistent storage volumes, your network connections, IP addresses, everything. All persistent state gets migrated. So EMP is a fit for every type of application. I would say the only apps that EMP may not be a fit for is if you're running high-frequency trading to a point where even microsecond delay or pause in your memory, et cetera, is not tolerable to your apps, then that's not a candidate for EMP. But so that comes to the second part, which we said is very important for us with EMP, which is zero app disruption, right? Because we are live migrating these virtual machines, we do not need to take the pods down. And that's one of the big things with Carpenter. Yeah, go ahead.
Yeah, are we, when we're talking about migrating VMs, are we talking about VMs that are running on KubeVirt already via the cluster, or are we talking about taking a VM that's outside of the cluster, copying the hard drive, putting it into a volume, booting it up on the Kubernetes cluster via KubeVirt?
No, so these VMs are already running. So these are EVMs that we created. So
Okay.
they're already running on KubeVirt originally on the bare metal node, and then we just migrated over to another bare metal node.
Got it. Makes sense.
Yep. And so as I was mentioning, tools like Carpenter, one of their side effects is that when they do this consolidation phase, they have to kill some nodes to move parts to other nodes in order to save space and save money. But that invariably results in pod disruption. There are apps that can't handle it, right? If you have a slow start, if you need to load a lot of data in the memory, you can't really handle, your parts getting disrupted. So that's a big thing, we think, with respect to EMP. And so, this kind of naturally lends to the fact that we're able to make a big dent on both those buckets, right? The bin packing wastage as well as the allocated but underutilized capacity by just, over provisioning and then rebalancing capacity. And so what we like to achieve is we like to maximize on that green bucket. And while doing so, we're able to make a big dent on your ECAS costs. So just summarizing differentiation of EMP is just some tools in the marketplace that we come across most that we've taken as examples. But we are, by the way, complementary to all of these tools because we're not in the business of giving you the best cost visibility around your Kubernetes clusters, right? A lot of these tools do an excellent job at that. But what EMP is really good at is these top 4 things: optimizing usage by improved utilization, optimizing usage by bin packing, zero pod disruption, and eliminating that back and forth loop. Because we don't need to ask engineers to change their request limit values. We're just taking care of things behind the scenes. And so,
what level of reporting is included in the tool to help provide a feedback loop to the engineers? Because this isn't solving the actual problem, which is you're asking for way too much memory. Please stop doing that.
Yeah.
This is a Band-Aid on that problem.
Yeah.
So that my first question would be, what level of reporting do I have back to that person?
Yeah.
My second question would be, how is this licensed, or how much does this cost? How much am I paying to put the Band-Aid on the problem?
Yeah. Yeah, so to your first question, it's interesting. So the current version of the product, and this is still an early product, it doesn't give you full visibility into the request limit values, which is really what people want to see. But that's the consistent feedback that we've received, which is exactly what you said. Still give us, we know that you're addressing this, but give us that data still so we can take it to the developers. And we have all the data. So we plan on adding visibility into the request and limit values. Mm-hmm. Today, we just give you visibility across, and Peter will show that, CPU memory utilization and those stats, which are kind of the key stats that we measure.
Okay.
And then, sorry.
Yeah, and then the licensing.
And the licensing. So the way we license this is we only want to make money if we help you save money. So we're taking, I think our standard model right now is about 20 to 25% of the money that we demonstrate to you that we're saving with EMP. And so if we don't save anything, we don't make any money. And so we really want to put ourselves on the line there.
Shared risk, shared reward model.
Right. Yeah. Exactly. Okay. Yep. And it's nice in that it makes it easy for people to pass through budgets, et cetera. There is no extra budget that you have to allocate for EMP. It's just going to come out of your existing budgets.
Okay.
So, essentially what we're saying here is that the bottom layer is what EMP operates in, right? And that's kind of where we see ourselves as differentiated. And then the last point goes without saying is what we've seen is that the potential that the dent EMP can make towards your cost savings can be pretty massive. So if your utilization is 17%, without being too aggressive, if we can bring it to 30% or so, your costs are just gone down by maybe a little less than 50%, right?
So when you're saying you're a shared percentage of the savings, what happens in year 2, 3, and 4?
It's the same thing. I mean, so we always have to take a basis for before in terms of how we calculate the
So after
before
12
cost.
months, I take a new basis?
No, I mean, so essentially the way the model operates is we deploy a fleet of these elastic virtual machines on your behalf, right? We take a look at what the cost of those virtual machines would have been if you were not deploying them with EVM or with EMP, right? These would be standard EC2 VMs. They may be under your savings plan, EDP, whatever. We have a way to calculate that. So that's the before cost basis. And then the after cost is the actuals with EMP.
Okay, so this year I have 100 EVMs.
Yeah.
You save me 25% of that, so I have 75.
Right.
Next year I only have 75. Do I still pay you for that?
No, you pay for exactly what you deploy. So next year, if you just had 75, you would pay us for whatever we save off of that. But there's always a constant
I'm
saving.
going to pay you, if I save money off of the 75, if I save more,
so the number of VMs is not going down, right? Your number of VMs is always staying constant. It's the underlying infrastructure utilization that is going down, and hence you're saving money.
So if I had 100 units, I'll ask Campbell's question a different way, because I'm thinking the same thing. You got 100 units of cost in year one.
Yes.
You take it down to 75 units in the first 12 months.
Right.
Come to do my renewal with you guys, am I paying off the savings from 100 units? Am I paying the savings off of 75 units?
You're always.
How long do I pay off the savings of 100 units is my question. Because there's a point where that elastic breaks and I'm like, okay, I set that benchmark with you 6 years ago. I'm not continuing to pay against it, is where my head's at.
Right.
There's a point where that, maybe year 2, maybe year 3, kind of like, oh, okay. There's a point where that elastic breaks in that model. So I'm trying to understand that.
So let's say you have 100 GB of memory deployed, right, today, and you're using it inefficiently. So we help you bring that down to about 80 GB. As long as you have us deployed, you're always going to be deploying 80 instead of 100. And so we're always going to want to make money off of that 20 that we save.
And my point is that commercial equation works 1, 2, 3 years.
Yeah.
In years 4, 5, and 6, I'm like, I would have done some optimization by now. I wouldn't have been using 100. I'd have got smarter. I'd have figured it out. I'd have done something. I don't want my commercial model tagged to something I did with you 5 years ago.
Yeah.
Because that's assuming I'd be dumb for 5 years.
Right.
And I would have got smart at some point.
That's true.
Maybe not in 3 years,
That's
but maybe in years 4 and 5 I'd have figured it out. But you're tagging my commercial model back to year 0.
Yeah.
That doesn't make sense to me.
I think that's fair feedback. Yeah. I mean, I can see the argument that
I mean, it
I
makes
might
sense
get
as a good
better.
model for like years 1, 2, and 3.
Right.
I can see that. But at
That's
some
right.
point, somebody's going to go, I've been using this software for 10 years.
But
you want it tagged back to like 2024?
Right.
Not
But
really.
that's why you need this a feedback model, right?
Yeah.
So it will tell your users like,
I'm
hey
not
guys.
purely commercial.
Yeah, but in the end, it changed the culture of using resources. So we need to, the software will give feedback, and maybe people stop to need
So how
that.
do I pay for the software then? How do I pay for
Well,
platform?
if
You
that,
will lower the amount, like a base, like this 100 units you will do in the third year 80, right? So you will pay from 80. But
That's right.
the users
That's right.
needs to understand that they just require too much.
So
I
understand that I'm paying for 80. My point is the point you benchmarked it from is now so far ago.
so let's say you're
that that's
currently
degrading as a business model.
deploying 100 VMs and we get you to an equivalent of an 80 VM capacity, okay? What he's saying, which is accurate, which is that if we're also giving you that feedback loop, your VMs are getting configured, your workloads are getting configured so that your new starting point becomes about 80 units of VM. You always have the ability to do that, right? You have the ability to still optimize at the app layer so that the number of VMs.
I'm paying you on the.
Then you will pay us
180 there.
No. So then you will only in the next year, if your base unit is 80, you're only paying us off of savings we provide to you on those 80.
Perfect.
Yeah, that's why the force feedback is
I'm sold.
some feature that you need, For,
Yeah.
And
Sold.
I would presume that you're not just going to let that 20 lay there, right? You're going to be building new applications.
That's right.
And so forth.
That's exactly right.
There is a fee. Right, there is a feedback loop and there is a point
I'm
of,
only paying on my savings.
Yeah.
I'm paying these guys a percentage of my savings each year.
Right. Right. That's right.
You didn't say that way, which is what
That's right.
Amberly and I asked the question.
But you're right. It is each year. And I think what naturally what will also happen, we think, is you optimize these, but then there's new VMs that come into picture, which you're also going to put, right? So there's always that dynamic environment. But in the end, yes.
Sorry.
Yeah.
When we're talking
you for
about
the
8 million saved here, we're referring to the worker nodes as a whole, right?
That's right.
We're not referring to the VMs running on Kubernetes.
No, well, in terms of what saved, when we talk about 8 million saved, it is you would have paid. Let's just make this simple example. Let's say it was, we saved you 50%, then you would have paid 16 million with the EC2 fleet that you were going to deploy, and instead we consolidated to, let's say, 5 bare metal nodes, right? And they cost you $8 million.
Okay. Pardon my ignorance. Perhaps you answered this already, but if we're talking about bare metal and we're talking about EKS, are we then talking about AWS Outposts and EKS Anywhere?
Yeah, we're not. Because so AWS, what it allows you to do, and now Google and Azure also let you do that, just like you deploy EC2 nodes in AWS, you can deploy bare metal nodes in AWS. They're called EC2 nodes. So we're talking about those. We're not using Outposts.
Okay, got it.
Yeah, and EKS Anywhere. Yeah.
About the hybrid approach or something like that.
That's right. No.
And then these EMP nodes, these are just running as a separate node pool in your EKS cluster?
That is exactly right. And Peter will show you. And you can have mix and match. You can have your EC2 VMs and some EVMs. So
got it.
That's exactly what it is.
And that's if it's a separate node pool, it's able to see all other node pools.
That's right.
Right?
That's right.
Got it. Makes sense.
Quick question. You mentioned AWS a lot. Is it the others as well?
So today the product is just focused on AWS, the first version. But I mean, as you can see, the tech is not limited, and we actually plan on expanding it to AKS and then potentially GKE.
Okay.
So, and in fact, we think the tech also applies itself to just pure EC2 fleet as well. It doesn't have to be Kubernetes. Just EC2 VMs today are very underutilized. So
Yeah.
Yeah.
Kind of almost even worse.
Right. Yeah. Exactly. So